Hello students, today I will discuss about second chapter of chemistry, acids, bases and salts part 1. In this discussion, we will discuss about classification of compounds, acids and their types, bases and their types, indicators and their color changes with acids and bases, characteristics and reactions of acids and bases, dilution process of concentrated acids, strength of acids and bases, pH scale, universal indicator and its uses, importance of pH in daily life, uses of acids and bases, and examples of strong and weak acids and bases. You know, till date we have discovered 115 elements. These elements combine to give enormous number of compounds. Mainly, these compounds can be classified as acids, bases and salts. Acids can be classified as with the basis of sources, strength and concentration. On the basis of source, acids can be classified as organic acid and mineral acid. Organic acids means sources are plants and animals. Mineral acid sources are minerals. Strength, strong acid and weak acid. Highly ionizable in water in case of strong acids, and in case of weak acids less ionizable in water. On the basis of concentration, the amount of acid in lesser amount is called dilute acid, and higher amount is called concentrated acid. Similarly, bases also can be classified as strong and weak base, dilute and concentrated base. Again, solubility in water, the bases can be divided on the basis of solubility of water. The water soluble bases are called alkali and others are simply bases. So, all the alkalis are bases, but all bases are not alkalis. Salts are produced when acids react with bases. Salts are produced from an acid by the replacement of the hydrogen in the acid by a metal. Next, indicator. An indicator is a dye which changes color in acid or base. Indicator can also be classified as synthetic, natural and olfactory. Synthetic indicators, example, methyl orange, phenolphthalein, etc. Natural indicators, turmeric, red cabbage extract, litmus. Olfactory, vanilla extract, onion extract. Now, for synthetic indicators, color changes: methyl orange in acid, red, in base, yellow. Phenolphthalein in acid, colorless, and in base, pink. Litmus in acid it is red, blue litmus changes to red, and red litmus changes to blue. Now, color changes or smell changes. Color changes of litmus, turmeric, red cabbage extract, hydrangea, naturally blue, are in acid solution. Litmus, blue litmus changes to red, turmeric, yellow, red cabbage extract, red, hydrangea, blue. But in basic solution, litmus changes to red, litmus changes to blue, turmeric changes to red, red cabbage extract changes to green, hydrangea pink. Now the change in smell. In acidic solution, onion extract and vanilla extract will not change their smell, but in basic solution they destroy smell. Now, characteristics of acids and bases. Taste In the acid, taste is sour. In base, taste is bitter. Color changes. Blue litmus changes to red in acid. In base, red litmus changes to blue. Conduction of electricity. Both acids and bases are conductor of electricity, hence both are called electrolyte. When dissolved in water, all acids produce hydrogen ion aquated, that is H3O plus. All bases produce OH minus aquated ions. Reactions of acids. Zinc plus H2SO4 gives ZnSO4 plus H2. This H2 gives a reaction with oxygen and fire to produce 2H2O liquid dropwise with pop sound. Calcium hydroxide plus carbon dioxide, that is lime water, changes to milky when carbon dioxide is passed through calcium hydroxide, it produces calcium carbonate and water. Calcium carbonate plus water mixture, when excess carbon dioxide is passed through it, it produces calcium bicarbonate solution in water. Now, the carbon dioxide is coming from sodium carbonate and sodium bicarbonate. When reacts with acid, it produces carbon dioxide. Now, acid-base reaction. When acid reacts with base, it produces salt and water. When metal oxide reacts with acid, it produces salt and water. Now, the reactions of bases. Bases also react with metal to give metal salt and hydrogen. For example, zinc plus 2 NaOH gives Na2ZnO2, sodium zincate and hydrogen. Again, similar reaction, when base reacts with H2SO4 or any other acid, it produces salt and water. Concentrated acid can be diluted by mixing it with water. That is, concentrated acid is mixed dropwise in water by stirring the mixture with a glass rod. Dry acid, such as HCl vapor, cannot change the color of dry litmus paper, but wet litmus paper shows color change. Aqueous solution of alcohol and glucose do not show acidic character because they do not produce hydrogen ion in their aqueous solution. Strength of acids and bases can be measured by pH scale. pH is mathematically negative log of hydrogen ion concentration. Hydrogen ion concentration increases, acidic strength increases, pH value decreases, basic strength decreases. Now, pH scale. In this pH scale, it is ranged from 0 to 14. 7 is neutral, more than 7 is basic, less than 7 is acidic. Now, universal indicator. It is a mixture of different indicators or dyes which changes color at different pH. When pH 0, the color is dark red. When pH 1 and 2, it is red. pH 3 and 4, orange. pH 5, orange yellow. pH 6, greenish yellow. pH 7, green. pH 8 and 9, blue, deep blue. pH 10, 11, 12, purple. pH 13 and 14, violet. So, from the change of color of universal indicator, we can approximately get the pH of the solution. Now, importance of pH in everyday life. Plants and animals are pH sensitive. Human body works well with the pH range 7 to 7.8. Plants are grown in the soil of certain pH range 4 to 8.3. pH in our stomach is 1.4, and that is why it helps digestion of food as well as it kills the outside bacteria or microbes coming with food. Cause of tooth decay. If pH of our mouth decreases to 5.5, then tooth decay starts. Tooth decay means acidic condition, it eats up the enamel of the tooth. Self-defense by plants and animals. Bee sting, nettle leaves and wasp sting are used for self-defense. Bee sting leaves an acid, so to prevent it, we must use baking soda. Nettle leaves inject methanoic acid, HCOOH, using baking soda is the preventive measure. Wasp sting leaves a basic liquid, and hence for prevention we must use vinegar. Acid rain. When the first rain of the monsoon make the water of pH 5.6, it is called acid rain. Now uses of acids and bases. Uses of acids. H2SO4 is used to manufacture ammonium sulfate, paint, dye, plastic, synthetic fiber, detergent, explosive, car battery, etc. HNO3, fertilizers, explosive, dye, plastic, etc. HCl, to remove oxide layer on metals before galvanization. Preparation of dye, textile, food, leather, etc. can be used. Acetic acid, vinegar, pickles, medicine and other organic synthesis. Now the uses of bases. NaOH, used for soap, paper, rayon. Calcium hydroxide, bleaching powder. Magnesium hydroxide, antacid. Sodium carbonate, softening of hard water, washing soda. Sodium bicarbonate is used to make baking soda, baking powder, soda acid, fire extinguisher, etc. Now, some examples of weak acids and strong acids. Strong acid, HCl, HNO3, H2SO4. Weak acid, methanoic acid, ethanoic acid, carbonic acid. Some examples of strong base and weak base. Strong base, NaOH, KOH, BaOH all twice. Weak base, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, etc. So, this is the first part of the chapter acid, base and salts. So, please see the video time and again, and if you feel it is difficult to answer, please comment on this video's comment section. Thank you very much.